Okay. Good evening, everyone. Good evening, good evening, good evening for Insola. How was your day? Good evening, Anolua. Good evening, everyone. Trust our day was good. I'm happy to see us. Hello, Leland. Good evening, ladies. Good evening, good evening, good evening. Good evening, pain influence. Hmm. That's struggling. Good evening. Good evening. So I trust that it was good. Let's just have a little chat while we give others about 2 minutes to join. So I believe our day was good. Well, how was our day? For those of us that are in Lagos, how is the traffic? Good evening, Onoa. So let's discuss how was the traffic. One more minute. Then we dive deep into today's lecture. Good evening. Good evening, Charity. Oh, Port Harcourt. Yeah, I know my day was good, but the traffic was something else. Traffic was something else. I think it's high time we start using exactly no fuel. I think it's high time we start using helicopter or all these big what are they calling the drones now that can take a person. So let's just give others about 1 more minute to join so we can move because I don't like it when you understand other people are trying to draw us back when we are moving. Practical will be like 3 weeks or 2 weeks before the end of the course, roughly 2 to 3 weeks for the end of the course. So there's still some services that we need to cover up. Helicopter, yeah, it's it's a 3 months training. Don't worry, practical is cooking. Practical is cooking. So let's dive deep in. So guys, I believe you have your bottled water beside you, or your hot tea, or your Zobo drink, something just to keep you on the move. Something just to keep you on the move. So let's go. Because I today's topic is going to be a very, very interesting one. 3 months. Okay, 3 weeks. Yeah. So let's dive deep. So who can quickly tell me what we did? That was today's Thursday. That was yesterday. Who can tell me what service we covered yesterday? No, we are still under AWS storage services. So who can quickly just tell me what we did yesterday? EBS and EFS. Good. Let's just use short term like this. I don't. Let's don't won't be using Elastly block storage or Elastly. Yes, EBS. That's good. EBS, EFS, EBS, EFS. So let's dive deep. Ha! I'm just excited. So guys, I'm going to take to this. There's no questions. There's no sorry. There are no time for we will have to answer questions and answer, and they are not demo because we really need to understand today's concept very well. Trust me. Yes, AWS storage services. So already, if you're ready, can I get a fly? Can I get a fly? I need 3 flies. Then we can move. 3 flies. Anybody? One, two. This fly is huge. So three. Okay, 4, 5. Okay. So AWS storage services. So guys, ladies, sit back and let me take you on a ride. So this is going to be an overview of AWS backup and disaster recovery. So I want somebody to say disaster recovery or just say the word disaster. I want this word to sink. I want some people to just type disaster in the comment section. Everybody. If I'm not getting everybody typing disaster, the comment section, I'm not going to fly you. So can I get it? Disaster. And don't just type it. I want you to let it sink. I know why I'm saying this. Disaster. Yes, yes. And let me check how many people we have. So I believe we should start telling ourselves that we should quickly disaster. Yes. Sorry about that. Disaster. We have about 42 watching. Disaster. Yes. Disaster. So let it sink, oh, let it sink. And we all know what disaster means. Let it sink, oh. Disaster, yes. There are still so many people. Disaster. Okay. I need 10 more. 10 more. Nobody, if you know you've done before, don't go and be helping one other sister. Sisters, don't help yourself. Okay. Disaster. I need 8 more. Let's talk to ourselves. So I will not fly you. I want to move. Oh. Disaster. Okay. Wake up, wake up, wake up, wake up, wake up, wake up, wake up. Yes. I want everybody to get involved into this teaching. Disaster. Okay, let's say I need 3 more. 3 more. One. Yeah. One more now. No. Olusola, not disaster. So I won't collect this one. Olusola, disaster. Let's wait for Olusola to send another one. in those things was yes. Olusola, I'm waiting for you. Yeah, miracle disaster. There's some people I know that they're always attending the class. It's like we'll start sharing chinchin. We'll start sharing chinchin. I'll come with chinchin. Those yeah, Olushola disaster. So let's dive in. So let's dive in. Good. Mr. Um, Technician, kindly move me towards my right hand side, please. Kindly move me towards my right hand side. I'm blocking the view of many. And buns. Okay, one buns. You don't like chin chin? I'm just waiting for them to move me away from here. Mhm. With kunu and zobo drink. Okay, Mr. Technician, please kindly help me move me. Okay, down. Just kindly move me down. Like down. Don't move me exactly. Exactly. Thank you very much. So let's get the definition of disaster. So what comes to your mind when you hear of disaster, recovery, and the cloud? So guys, let's move chin chin with chin chin, fly away. No cold zobo drink, no kunu, chin fly. This time around, we need to focus. Let's go of the chin. Let's go of the kunu. Let's go of everything. Let's go of this of the zobo drink. Now we need to focus on AWS. So AWS definition of disaster recovery is the process by which an organization anticipates and addresses technology related disaster. So this is a very simple definition. Okay, so just say it as any event that has a negative impact on a company's business continuity or finances is a disaster. So guys, I believe we are following now. So this is a simple definition of disaster recovery. Now, for any business, any organization that wants to remain strong or that wants to be able to meet the customer's need and be how will I put it now and be what word can I use again? So we need to meet the customer's need and always be ready to deliver, must always prepare for disaster recovery. So you understand? Let's say disaster now, prepare for disaster recovery can be like a company that is selling Kuno. Oh, Kuno has entered my head. Oh. Okay, let's just say they're selling Kuno. You know, say a big company that's selling Kuno. So that company is selling Kuno. In order for the company to prepare for disaster recovery, the company might should have another company that's company A and have another company B. So just in case something happens to company A, what happens? They fail over or they move to company B and their business continue going on. So that's just um, uh, disaster recovery. So all this definition is just for us to know. So disaster recovery is about preparing for and recovering from a disaster. Sorry. So what kind of disaster recovery? So DR. So from on-premise to on-premise, so that's a traditional disaster recovery and it's very, very expensive. So when you move from on-premise, yeah, let's focus now, please. Kunu should not enter the lady's head. So moving from preparing for disaster recovery from on-premise to on-premise. So that's the traditional disaster recovery, and we all know that that is very expensive. We'll be saying that over and over again. So the other one we have is the hybrid recovery, where you have some of your um, some of your resources on-premise and also in the AWS cloud. And the other one I just spoke of when I was giving an example now, for example, is AWS cloud region. So, for example, when you have a resource in cloud region A, and also have a resource in cloud region B, she get it. Say maybe application in one in region A, another application in region B. So in case of disaster recovery, you can quickly move over to region B, which is it is very possible in AWS. But one thing I want us to understand when we want to talk about disaster recovery is two terms. Now, this is where it's going to get very, very interesting. Two terms, RPO and RTO. RPO and RTO. RPO and RTO. I'm not saying DPO, I'm saying RPO and RTO. That's recovery point objective and recovery time objective. So these two terms really, really matter when we are talking about disaster recovery, when we're talking about resilience. So I want us to move to the next slide and let's see. Let me quickly explain when we talk about disaster recovery. So you can see this is the, let's say, a client or a developer or anybody, or let's say anybody, a client. So you understand the person is actually having access to this system or this server. Then all of a sudden, this server just got burnt. So what happens, because he or she already has another server that is going on, you understand, that's already on standby, quickly they fail over. So they have little downtime. So you get it now. As you can see now, she has already moved to the other server. So these are the things we prepare for. This is why disaster recovery is very, 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 very crucial. I believe we can all see this diagram, and if we can see this diagram, we already understand what we are talking about. So every other term we'll be using, just try and align this with it. So let's move. So why disaster recovery? Why is disaster recovery very important? So outages come in many forms. So anything can happen. Anything can happen. You know, most especially if you're in Nigeria, anything can happen. I don't understand. Olusholabu, sir, when are we going to conclude Monday's class? What's in Monday's class? I don't understand. Olubusola, sorry. Busayo. Just drop what you think is in Monday's class. So I don't really. Monday's class was concluded. Hmm. See this Monday. Okay, you meant the video. I've done the video for the bucket policy. Yes, see, it's not just S3 bucket, it's bucket policy. It's creating a bucket policy. And I believe my colleagues they've already uploaded it. How many of us have seen the demo has been sent already? Yes. So you can go through it. I created it. So you can go through it. It's already on the LMS. Yeah. I think Mr. Technician, I think it's high time you remove me away from the road because I don't want me to be disturbing. So sorry. Just kindly move me away from the road. Maybe just put me around here. So let's go. Why is disaster recovery important? Why is it very important? Like people, organizations prepare and plan for disaster recovery. So, for example, an earthquake or a fire outbreak, technology failures, system incompatibilities, many, many. Is in this case now you can see some people. Sorry. Okay, let's move on. So disaster, so simple human error, and the rest of them. So this disaster disrupt business operations, cause customer service problem, and result in revenue loss. I'm sorry, I want to just get the message. So, okay. So, I believe we are following. So, a disaster recovery plan helps organization respond promptly to disruptive events and provides key benefits. So, I believe with every explanation, we already know um, what we've been talking about disaster. I say we should let it sing, like be singing disaster. Maybe that's what we would have done instead of just saying it. I would have told us to sing it. So disaster recovery enables the following benefits. So ensures business continuity, enhances system security, improve customer retention. So we all understand what customer retention is. You understand if there's a disaster and you plan for recovery, you will always have customers coming. So they won't go and say, unlike some of our banks now, some customers, like some of us have actually moved away from some back when uh, you notice their ATM machines are now answering, or all of a sudden you just start deducting 100 naira or 15 naira from your account. So you get it. So let's move on. So now let's explain the term RPO and RTO. Yes, like Zenith. No, let's don't call any name. Me, I'm not calling any name. For instance, let's don't call any name. Eh? Me, I'm not there. Let's don't call any name. So let's carry on. Now let's understand what RPO and RTO means. So I want us to, if you want me to fly, tell me fly. I believe we are smart ladies and we are highly intelligent. So if you want me to fly, can I get a fly? If you understand from this all what we've been saying to this very point, oh wow, you guys are following. I like that. So RTO. So RTO is a measure of how quickly can your application recover after an outage. Now this is, let me see. So RTO is a measure of how quickly, take note of measure, how quickly can your application recover after an outage, and RPO is a measure of the maximum amount of data loss that your application can tolerate. Now, let's take each of them. RPO first, recovery point objective. So this is the maximum amount of data you can afford to lose, that you are willing to lose, or you are willing to lose. Now let's look at an analogy, for example. So think of it like taking photos on your phone. So those of us that are using, everybody's using smartphone, and so that are using iPhone, I salute you. Those of us that are using Samsung, I throw away salute. Those of us that are using the other phones, you get it. So you guys are actually, all phones are phone and phone. So think of it like taking photos on your phone. So if you take pictures every hour, your RPO is 1 hour. That's a recovery point objective. If your phone breaks, you might lose the last hour of photos. So for every hour, you are willing to sacrifice an hour of data loss. So every hour. But recovery time objective, so is how long it takes to get back everything up and running after a problem arises. Now let's take an analogy. Imagine your favorite restaurant closes for repairs. If they say it will take 2 hours to reopen, then their RTO recovery time, now this we're talking about time, is 2 hours. That's how long you will have to wait to eat there again. So RPO, the amount of data you are willing to lose, to let go in the course of a disaster. RTO is the amount of time it takes for the application to pick up again. I believe we are good. So, in summary, how much RPO, how much recent data can you lose? Let's say 1 hour of photos. RTO, how long until you can use that service again? Yes, I know this will come up. So throw the questions. We'll digest this RTO. See, today I purposely I wanted to even eat a bar before coming, but I'm trying to I got here some minutes before, so because I know questions will come up with this RTO and RPO, but I believe we can withstand it. So can we say for RTO there are no loss of data? No. Now see, now there's when we start looking at our disaster strategies, we are going to see we have about 4 of them. Yes, sitting and teaching for 2 hours is no joke. Are you guys even sitting down and looking at your screen, just looking at the guy speaking? Trust me, you need some food like eba, fufu, all those eba that if you throw it on the wall, it will come back. So when you sit down like this, you can be talking for 2 hours. You will not shake. So throw your questions. Let me see which one I'm going to quickly address. RTO, RPO. Okay, I'm not understanding RPO. I will come at it again. Any other person? Any other person? Yes, those kind of a bad. If you eat it, you will need to add soup very well so you can pass the esophagus, or else something can happen. So I need some persons to explain the RPO again. Okay, no problem. That's what I'm here for you, TJ. Any other person? Let me go over it again now. Now, both of them are measurements, have to do with time. Every one of them have to do with time, but one has to do more with data, the data you are willing to lose, the data you are willing to lose. So the maximum amount of data. Let's say, for example, what analogy can I use? Let me see. I guess I put some analogy here. Let me come in. Come in. No, before we move to, please have the similarities and differences. The similarities and differences are going to be very clear once you are able to understand the explanation. Just RPO is the amount of data. We are talking about disaster. When a disaster strike, let's start from there. When a disaster strike, packer like this, maybe a fire outbreak hits a particular bank. No, we can't say bank. What can we say? Someone should give me an example. So to give me an example, I've been saying bank, bank, bank. I've been saying food. I've been saying restaurants. Give me an example. Someone should give me an example. Let's say, let's talk about, give me an example maybe of a company, refinery, deep, data center, okay, hospital, let's use a service provider office, okay, hospital, A cyber cafe. People are truly tech sisters. So, okay, since I get to hospital, let's say two hospital now. Two hospital. Fire disconnection at the public sector. Okay, since hospitals came up, so let's take hospital. So now let's take an hospital, for example, where you understand patient, let's say general hospital. For example, patients are coming in, trooping in, you know, stops are happening. And for example, the alarm just triggers off and they say it's a fire outbreak, which some people in as Nigerians, once we hear run, we don't even wait to look for what is going on. We you get it, we move. So let's say the alarm just goes on. Okay, let me quickly. Okay, so a saloon. So let's say the alarm just goes off on goes on, for example, and they say there's a fire outbreak, everybody evacuate the building, and it takes the next hospital, it takes like um 10 minutes of walk from there to the other hospital. So now, how many hours or how many amounts of let's say data or patients, let's use patient, they are willing to forfeit at that particular time? Because after that incident, some patients might decide to move to another hospital quickly, or let's say how many hours it takes for them to recover from that fire incident, for them to check what's going on, for them to find out what's the exact problem, how many hours. And once they notice it, they're going to stop every um, process. Let's don't say moving to another hospital. How many hours does it take for them to quickly discover it within the hospital? So let's say they've set up a disaster plan that, let's say, for example, if a fire outbreak comes, which is not really a serious fire outbreak, maybe someone just mistakenly left the gas on, you understand, and all of a sudden the alarm just goes off. So how long does it take for them to for them to quickly let's first of all talk about RPO. So how many hours of data or how many hours of time are they going to allow every services to stop going? Okay, you are not understanding it. Okay, let's use WhatsApp for example now. Okay, let's use WhatsApp. Let's use WhatsApp for an example now. Let's say how many of us, every one of us is using WhatsApp. So let's say for example now, hmm, let's say for example now, um, every one of us is using WhatsApp, and WhatsApp. Most sometimes they can tell we can the one we are using can expire. Okay, don't worry, I'm going to use another term. So let's say the one we are using can expire. You understand? How many amounts of data we are willing to forfeit when that WhatsApp app is no longer faulty, sorry. So how many amount of data we are willing to forfeit when that WhatsApp is no longer is faulty. Then the other one is going to be RTO. How long does it take? That's the time. How long does it take to get everything back on? So it can take for, let's say, when you're trying to restore your backups and everything, it can take for like there about 15 to 20 minutes. Okay, we can't use Etisalat, we can't use Airtel, Etisalat or MTN. Let's just use WhatsApp. So I don't know if we understand RPO and RTO. Set a backup every. Okay, so RPO is 1 day, which means. So in a nutshell, RPO is the amount of data you are willing to lose when a disaster strikes. Now, when the disaster strike, let's say you are willing to have like 30 minutes or 30 of 1 day of data. Sorry, notifications are coming up. So 1 day of data, or 1 day, let's just say 1 day of data before the before you recover, come back online. Then the time, how long does it take for everything to come back on? Exactly, exactly. So wait, if you don't understand it now, let me know so I can quickly come back to it. Let me use another example. So if you don't get it till now, let me know. Yes, RTO has to do with time. Yes, exactly. Yes, we are getting it. Yes. Okay. Hmm. Professor, so your RPO is 1 day, which means that if anything happens to your WhatsApp, the last chat. Hmm. Okay, let me just get everybody. Okay. Okay. So all we're already answering it by ourselves. Okay. Okay. So yes, okay. Okay, you want to use another example. Okay, let's use WhatsApp now. Let's use WhatsApp now. So let's say you back up your data 24 hours, or let's just say 1 day. Oh, armed robbery does not cut it. Okay, let's just use, since one person does not understand, let's use a WhatsApp now. Let's say your WhatsApp, for example, how many hours, or let's just say you back up every day, every 24 hours. So you are willing to forfeit a day's chat when a disaster happens. So how long does it take for you to recover from your chat? That's going to be your RTO. That's going to be your RTO. So for the backup, for the WhatsApp backup, let's say it takes, you've already set your backup to be like 24 hours, that's a day. So your RPO is going to be 1 day. So if, for example, if let's say something happens or your WhatsApp just has one or two faults, so how many of us knows it takes some time for the WhatsApp to come back on? You understand? For you to restore your data, your chats, and everything. So if it takes 24 hours for the data to be available, so now how do we measure the RTO? So how long? So the time that it takes for that data, let's say it takes like let's say a day to for the data to come back online. That's the time. So it's going to be 24 hours of RTO and 24 hours of RPO. I believe we should get it now. Can we use frame memory for an application? Yeah. How long do you do? Is it not taking your time with? Maybe we'll come back to this RTO and RPO again. Let's come back to this RTO and RPO again. So, in summary, how much of data, when a disaster strikes, for example, how much of data are you willing to lose? How much of data are you willing to lose? And how long does it take for it to come back on? That's the RTO. So let's move. So if you look at it here, so the recovery point objective, that's the data loss, how much of data you can afford to recreate or lost or lose rather. So how quickly must your recovery? What is the cost of downtime? I believe we already understand it now. So let's move. So when it comes to disaster recovery strategies, there are four in AWS. Okay. We'll come back to this RP and RTO. So backup and restore is one, pilot light is another one, warm standby is another one, multi-site active is the last one. So if you want me to go on, let me know. If you like me to go back again, let me take my time to go back again. So we are going to discuss it. If RT and RPO is not clear, okay. So disaster recovery strategies. Let me go back to RTO. Let me go back to RPO and RTO one more time. So now let's look at the definition. Let's look at the definition. Now, think of it that you're taking photos on your phone. RPO has to do with the maximum amount of data you can afford to lose. Data, how long, if a disaster strikes, how long it takes for the data to be back on. That's RTO. RPO is the amount of data, the maximum amount of data you can afford to lose. So if you think of taking photos on your phone, so if you take pictures every hour, your RPO is going to be 1 hour. If your phone breaks, you might lose the last hour of photos. So how long, I'm sorry, how many hours of data is they are willing to lose is just one. So RT on the other hand is how long it takes to get back everything up and running. So imagine something happens in a restaurant or thereabouts and some issues, you understand, just come up. How long does it take for everything? So now we are using time. How long does it take for everything to come back up? That's your RTO. That's your RTO. So you just have to understand the two terms. RPO, the maximum amount of data you can afford to lose or to lose. RTO, time, how long does it take? So you calculate the time. You can set the time to 2 hours. You can set it to 3 hours. I can afford to take 3 hours. So let's move. So we have disaster recovery strategies. So let's take them one by one. So we can see this is a graph that shows um, disaster recovery strategies. Now, in AWS, the one that is very, very easy to get is this one. That's the last one. Multi-site active. I don't want to use technical terms much. I just want us to do normal language, very simple terms that we can understand. So you understand? That's why I'm using analogy and the rest of them. So I'm going to be very, very simple as possible. So the last one, that's multi-site active. Let's quickly clear this last one now. So active. So let's say you have two buildings that are running your application. You understand? So real time is happening. If, for example, one something happens in the other building, you don't have any issue. You're not going to, in fact, you have zero downtime of recovery if a disaster strike region A, for example. Region B is always up and running. So that's active. Everything going on region A is the same thing going on region B. Okay, I can see I'm already flying. So the other one that we are going to focus on more is active passive. And so that's backup and restore, pilot light, and warm standby. So let's dive into them one by one. So backup and restore. So this is the most basic and cost-effective DR strategy. So one thing I want us to know is this. If you pick backup and restore, if you pick backup and restore, is very, very cost effective because you don't have more of your data running in another um, um, building. So now, before we even go on, let's use, we are looking at two buildings here now. So let's take the picture of two buildings, building A and building B. And we are going to use a bakery as an example now. We're going to use a bakery as an example. If you are getting it up onto this moment and you would like me to move on, can you say fly, please? Can we say fly, please? Can I get a fly? Okay. Okay. So we are going to be using a bakery. So think of this, a bakery, two buildings of bakery. Thank you. Two buildings of bakery. So let's take it. So this is the most basic and cost-effective disaster strategy. You back up your data. So to S3. Now, generally, S3 is a storage device. So every of your data, even after you've moved it to, let's say, a small storage device, let's say like EBS, behind the hood, every of your data is moving from EBS to S3 storage. So that would be for the associate level, but it's something I just want us to know. So let's look at this analogy. Imagine you own a bakery. So every night you take photos of all your recipes and store them in a safe. Now, you take photos of all your recipes and you store them in a safe. If the bakery burns down, you will need to build a new bakery. You see the time it takes, and use the saved recipes to start baking again. Now, remember, you have a small portion somewhere. That's the photos of the recipe you've taken. But it's just there. The recipes have not been used, they are just here. So it takes time to rebuild, but you have everything you need to build again. So that's for backup and restore. I'm going to, if you understand backup and restore, let me know. I want to be taking this very, very slow. So if you would like me to fly from this place, tell me fly. If you want me to come back, say okay. I just need 5. Okay. I've seen Onoa. Okay. What's her name again? No. That's other people. Okay. Oh, Uju is new. She's slow. So, like I told us, have 2 buildings at the back of your mind. There's somebody's flyer I'm not saying. Forgotten her name again. Yeah, Miracle. And what's her name? Okay, let's go on. So, think of a bakery. Okay, yes, I know Lua, and there's one other person too. Okay, so let's take it gradually. So, let's move to the next one now. So, look at the diagram. Now, if you look at it, now this is a cross region backup. Now we are just dealing with S3, we are dealing with storage, and you can see we have everything in this storage. So this AWS backup, as you can see, this an S3, a bucket, this is an S3. So you have the recipes and everything inside this bucket, but it's not functioning, it's just there. You can see on the other hand, you can see on the AZ1 and the AZ2 and the AZ2 rather. Hmm? You'll see your applications are running in AZ1 and you see the storage devices here. But in case of a disaster or something happens, everything is always in this other bucket. So it will take time, but it's very cost effective for it to pick up again and start afresh. So let's move on. Don't worry about the diagram too much. So now let's look at the other one. So sometimes me myself, I don't know why pilot light has to be the word they use for the second one. I usually mix between pilot light and I usually mix between pilot light and warm standby. So let's look at pilot light explanation. So a small critical portion of your infrastructure is always running, such as your core database, while the rest, like application servers, are not. So in a disaster, you quickly scale up additional resources based on this pilot light. Now, let's see. So imagine your bakery is always stocked with the ingredients needed to bake your most popular bread, but you keep the ovens off. In case of emergency, like a rush of customers, you just turn the ovens on and start baking immediately without needing to gather all the ingredients again. So we can see difference between pilot light and a backup and restore. So the time it takes, the RTO is moderate, is little. That's the time it takes to come back on compared to the backup and restore. Hmm? So if you understand it to this point, can you tell me to fly? I would like me to stop and explain again. Okay, okay, okay. So please just feel free. Let's don't rush. If you know you are not getting it, just let me know. If you are not getting it, I will gladly explain again. Okay, so we are doing so in the next few minutes we're going to be on break. Sorry, I want to quickly plug my system. So we are dealing with a bakery here, and we started with backup and restore. And we said you can have a photo of your recipes that you've actually keep. Okay. Okay, guys, don't worry. I'll take it over again. No problem. I'll take it over again. Maybe we are going to go for a break and we will come back. Comment. I'm just trying to get a confirmation, and don't worry, I'm going to explain it again. I guess we are going to take our attendance now and we'll come back. So one thing I just wanted to understand is RPO and RTO. If you understand RPO and RTO very well, trust me, every other aspect of this is going to. Oh, bossy, I guess you're just coming. So let's take our attendance. I can't see the attendance up, so maybe we are going to continue. No, for backup and restore, the ingredients are in a place. You understand? Think of it that you just have, you understand, the recipes and everything. You just snap the recipe. You understand how it runs and everything. You can take some breads and not just normal bread. It takes time to actually cook, to prepare them. So their recipes can be more. So just think of you taking a photo for the backup and restore, taking a photo done with the attendance. So the attendance, oh, say let's mark the attendance. I'm not getting anything. Let's mark our attendance. Some people are already marking done with the attendance. Hello, so sorry. I believe we're all set. So sorry, don't mind me. So sorry. So let's start again. Hmm? So if you want me to fly, just tell me to fly. So sorry. So if you want me to fly, just tell me to fly so we can proceed. Can you hear me now? Uh, okay. So we're talking about disaster recovery strategy. Disaster recovery strategy. Now, we are going to be using a bakery for example. Let me take it back a little bit. So now, the time it takes for a disaster to recover back, it can be it can be 1 hour, it can be 2 hours, it can be 3 hours. Now, the smaller the time, the costlier it is. Hmm? So have that at the back of your mind, and let's move on. So the first one I said, imagine you own a bakery, and every night you take photos of all your recipes. You take photos of them, recipes. Every lady here knows how to cook. I know I'm not wrong. Every lady here knows how to cook, and I mean cook very well. So if the bakery burns down, we are focusing on disaster. That's why I said have that back of your mind. Understand disaster, 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 disaster. That's why I told us to repeat it several times. Hmm? So you already have every photo of your recipe. You understand? So a building, excuse me, a building has a fire outbreak. That's the main building. What happens? It takes time for you to build another building. Hmm? It takes time for you to get the recipes. You understand that, but you already know the recipes and everything because it's in photo. Huh? So let's move gradually. Now, pilot light. But this time around, a small critical portion of your infrastructure is always running. Now, such as the core database, while the rest, like application servers, are not in a disaster, you quickly scale up additional resources based on this pilot light. Now, let's take the bakery again. So imagine your bakery is always stocked with the ingredients needed to bake your most popular bread out of other bread, but you keep the ovens off. So these are the servers off. So think of the ovens as a server. So in case of an emergency like a rush of customers, you just turn the ovens on and start baking immediately without needing to gather ingredients. So you see the difference between the two of them. So take note that this one is much more faster than the backup. That's the time it takes. You don't have to start building. You don't have to start from the ground or start gathering the ingredients. Hmm? So if you, because you have, yes, because you have some of them in reserve, but at the moment they are not ready. So you understand, it's just a popular bread. I don't want to use technical terms so we can understand this. Now, this architecture, I don't know if it's clear enough. So, one thing you should just take note of, the analogy for pilot light is not a disaster, and it's confusing. Okay, for pilot light, what I want you to focus on is the fact that you have the what are they calling it now? Your ingredients ready on ground. So they are no longer in photos like your backup where you have to pick up everything. You understand? You already have the recipe. But in the time of pilot light, all you have to do is just to kickstart the oven. I know there are no buildings that caught fire or anything, but I believe this time is okay. So just have at the back of your mind that the ovens are off, that's the servers, but the ingredients and everything you need to make it are on standby. So you understand. So just in case of a customer comes in or there's a rush of customer, all you have to do is just to on the oven and you start baking immediately. So in the case of an IT term, your data is stored, your database is or is your that's your core database is already active. All your resources, all your the resources that you need, that's the data, sorry, and files you need are already in that database. So but the applications are not working. You understand? They are turned off. Okay, maybe we put in some technical terms, small, small. So if you see in this case here, how many of us remembers? Okay, I don't think we've talked about Route 53, but you can see we have two regions. We have region A and we have region B. And you can see right here, if you look down, you see the database. That's the Aurora database. So everything happens asynchronously. So this is a replica at the other region. So everything, your data, your files, and everything is automatically replicated inside this database. So just in case of any occurrences, any fire outbreak, everything is replicated to this. You don't have to start from the beginning all over again. So you understand, all you need to do now is to spin up the EC2 instances. As you can see, I believe you can see my cursor. All you need to do is to spin up the EC2 instances. So let's move. So now, warm standby. So a scaled down version of your fully functional environment is running at all times, allowing you to quickly scale up to full capacity in a disaster scenario. So you see the RTO is getting lower. That's the recovery time objective. So this one is quicker to it's quicker to recover. So you understand, but still requires scaling. Now, in the bakery, you have a smaller backup location with ovens and staff working at half capacity. If something happens to the main bakery, you can quickly scale up operations at the smaller location to match the demand. So now let's say, for example, you have, in this case, you have two bakeries. You understand? And you have little of the staff, you have the main building, and you have a smaller one. So just in case of anything happens. So virtually almost everything that is happening in the main building is happening at the other building, but it's just a small capacity. Now, in this case, it's just going to be some EC2 instances, some servers that are running at all times. Let's say, for example, you have um, two, 3 micro are running at all times. You understand? And you have your database fully running too. Now, if something should happen, you already have your servers running, some servers running. So it will take some minutes for you to scale up to meet the current workload that was happening at the main server, at the main building. Let me take it again now. Let's add some technical terms. Now, let's say, for example, now we have two regions now. We are going to be dealing with servers and we're going to be dealing with databases. Now, for the main building, you have the large EC2 instances that are running, which are meeting customers' need. You understand? And the database too, fully functional. You understand? So in the other building where you prepare in case of a disaster recovery. Now, what is going on in that building? The database is fully running, but the EC2 are not going to be the large EC2 instances. They are just going to be the small ones, like the T2 micro that are running, but they are able to work. They can't provide full capacity to meet the customer's need, unlike the main building. So if, for example, now, but there are other large EC2 instances, IAM, that are already on standby. All you have to do is just for it to, once you activate it and it starts working, it scales up. I don't know if you get it, or should I come back again? Do we get this warm standby? If you don't get it, tell me to come back again. I should explain the warm standby. Or if you get it, can I get a fly so I can move on? I get this. Okay. I know Lua most of the time. And if I know Lua can say she does not get it, I know Lua, and what's her name again? If I see her, I will know. About three or four of you. But it's fine. Okay, and Niniola. So let me come back again. Now, warm standby. Yes, miracle. So I think good example should be external drive and your laptop that we use for our business. So now we can't use a laptop, because when we now get to active, we cannot fail over to another laptop. You can't have two laptops. But let me take it all over again. So now warm standby. Now from the word warm, you have some of your services running in the other region, the core ones, but they are always running at all times. The main building is running the full capacity. Let's say, okay, now let's do it like this. We all know EC2 instances. So let's say in the main building, you are running 10 EC2 instances. That's the application server. And the database is going on in the main building. On the other building, even before disaster happens, you already have half of what is running in the main building in another building as a standby. The database is fully functional, but this time around, instead of having the 10 EC2 instances running, you will have 5 EC2 instances running. The other 5 EC2 instances are going to be there, but they are not working. All that has to happen is they have to just scale up, and you have to just activate them. That's all. So you have 100% running in the main building. You have 50% of the same capacity running in the standby building. So if a disaster should occur within few minutes, all that have to happen is for these two instances to scale. We all remember an auto scaling group. This is how backup works. No, this is not how backups work. Remember when I was trying to explain backup, I said you just took a photo of it. So in the backup is nothing is actually happening. Everything is just like a snapshot, like your facilitator explained yesterday. That was yesterday about EBS snapshot. There's also S3 snapshots. You understand? So for backup and restore, is mainly snapshots. No EC2 instances are running. No EC2 instances are running. No application servers are running. So we get for backup and restore. No EC2 instances are running. No application servers are running. You just have a snapshot of everything inside maybe an S3 bucket. It's way different. But on the warm standby, you have, like, let's just say 5 EC2 instances instead of 10 running. So, tech sisters, the way we are bringing up this analogies, I like it, Sha. You guys, I'm glad you're following. So, for those of us that have inverter, so like me now, I'm currently using my inverter to charge my laptop because they've taken light. So, but we can't fully use inverter like that. So, I believe you understand. So, let's take the technical term now. The technical term, let's start from backup and restore now. We have EC2 instances running, about 10 of them. We have databases running, very few of them, like let's say like 5 of them too. You understand? And we have an S3 bucket. S3 bucket, database in the private subnet. Have we done VPC? I don't think we've done VPC. So don't let me talk about private subnets. How many of us remember private subnet and public subnet? Have we I believe when I was explaining the architectural diagram, 3D architectural diagram, did I pull that up? Or how many of us know private subnet and public subnet? I don't think we've covered it. If you know it, can you just say you know it? Maybe I should use it, or let's just use, we have EC2 instances, about 5 of them that are running, 10 of them running in the main building now. 10 of them running. We have databases that are fully functional. And we have under the hood, we have an S3 bucket. Now, let's take backup and restore now. And we have another building. Now, let's say this is region A and region. Okay. So now let's use technical terms. I wanted to get to the. So now let's say we have 5 EC2 instances running in this region, 5 EC2 instances up. You understand? We are in 3 stages in region A, 5 EC2 instances running here, let's just say in a private subnet, and databases running here, you understand? In a private subnet, public subnet. Then we have an S3 bucket down that keeps the snapshots. Now we have another building. Now let's use backup and restore as an example. From the word backup and restore, what happens is this. The EC2 instances are in this place, but they are there, they are not working. The databases are there, but they are not working. The S3 bucket, the only thing that is in this S3 bucket is the snapshots from this one. So the objects, the what are they calling it now? The data and everything that the application needs to function. You understand? So everything fails over. So there's a replication going up from this S3 bucket to this S3 bucket. It's actually a snapshot. So if a disaster should strike, there is no need to start from the beginning, from the very beginning, because you have the snapshots here. But it's going to take a longer RTO, because for you to spin up the database servers, for you to spin up the EC2 instances, so you get it. So now we have to spin up EC2 instances, we have to spin up databases. So now let's go back to the pilot. Now let's move to the pilot light. For the pilot light, the same thing and the same thing here. But this time around, the EC2 instances are not working, they are fully dead. What are they calling it now? The databases are up and running. The snapshot is still going on, the replication is still going on. So now it will take, if a disaster to happen here, it will take for the EC2 instances to pick up. So now the RTO is even getting much more smaller, but then it's getting much more costly. That's for the pilot light. Now for the warm standby, remember we said we have 10 EC2 instances running up here now. No, my screen is not moving. I purposely not let it move. I'm actually explaining using technical terms now. Yes, Sandra, thank you. So now for the warm standby, now let's say you have 10 EC2 instances, databases, and S3 buckets. For the warm standby, you will just have 5 EC2 instances running. Your database is fully functioning, and your snapshot, your S3 bucket snapshot is still happening. So if a disaster should occur and region A falls down now and the fire should break out, it will just take for some few minutes for the remaining 5 EC2 instances to pick up and start working, for them to scale. I don't know if you get it now. Now, let's move to the next one. Now, active, active. So this one, everything that's going on here, like I've explained, is going on here. If region A should falls down now and just enter the ground, maybe there's an earthquake, no shaking. Everything that's happening in region A is happening in region B. Fully functional. Everything is happening in region A is happening in region E. There is almost zero downtime. So it can just take some very few seconds for everything to pick up here. So I don't know if we understand it now, or if you would like me to move, start all over again. Hmm? Anybody? If you want me to fly, say fly. If you don't want me to fly, say don't fly. Was I too fast? This one that we're not responding. Okay, it's like I'm going to the first 5 persons to drop their numbers are we. Let me quickly first 5 people to drop their numbers. Let me quickly send. Okay, we are responding. Okay, you don't want recharge card. Okay. Okay. When we hear recharge card now, when we hear send numbers, so people are responding quickly. The technical aspect is not well understood. Okay, so let's move back to bakery now. So let's move back to multi-site. Sorry, warm standby. Let's move back to warm standby. So now in the bakery, you have a smaller backup location with ovens and staff working at half capacity, like I said. Okay, so pilots sorry, warm standby. Don't go and say you will not respond again. So I can say send the number. I'm not sending any, you are not sending any number on A and B. Okay. A and B, okay. So not that if I say respond, you will not now respond. You will not be expecting me to say type your number again. I'm not going to say it again. No. If you don't respond, I'm going to continue speaking like that. So let's go on. Let me somebody saying A and B. So one thing you need to understand when it comes to disaster recovery is that there are four of them. Is the RTO is short. See, you guys, I'm not supposed to be looking at this comment, or else I'm going to be distracted. You will be letting me laugh. So somebody saying you don't understand from A and B. Let me take A and B again, because we are going to move to another section. So now, so this is the last time I'm going to take it. Who says she does not understand? Okay, Akinsugi, please. So now, like I said, for just taking an analogy of backup, it's just backup and restore. Backup. So you just have snapshots of everything that is going on in the main building. Let's use a building. Let's enter into technical terms. In the main building. So you understand. So you just have a snapshot of everything. Like you just took a picture of everything that is going on in the main building. For backup and restore. So it will take longer time for it to kickstart. We have the database that are lying dead. We have the EC2 instances that are lying dead. So you understand? So for backup and restore. So but snapshots. So just have that back of your mind that you are never starting from the ground again. You don't have to go and start getting anything. The snapshot and everything is happening of everything, of all your data and everything. But you need to scale up and start everything from literally almost the scratch. So as you can see here, the S3 buckets are the only one that are working at this, and it's just to store your data. You get it? People that I don't know now that I've not seen them replied, they started commenting on the started commenting. When we hear send your number. Okay. Let's move on. So now pilot light. Now, a small critical portion of your infrastructure is always running, such as your core databases. So now here, the databases are working. The databases are working, but the application servers are not working. Hmm? So when the what are they calling it now? The main building falls down or just gets burnt or something. You have your snapshots in the bucket, the databases are up and running, but the application servers that are meant to power the whole thing and do everything are not working. On the other hand, for warm standby, now in this case, in case there's a disaster, the snapshot is fully functioning, the database is working, you understand, fully functioning. Then some part of your some EC2 instances are also working, but not all for warm standby. So you see the RTO is becoming lesser. Sorry, Honor. So if you can see here, if you can see here, you see the front-end server AWS. So let's look at this. I believe we can see this. You see this region A and this region B. Let's say, for example, this region is fully functioning. Yeah, something like that, Sha. Something like that. So this region, you can see everything is working. The elastic load balancer is routing, is sending traffic to the front end servers. You see both front end servers in AZ1, sorry, in AZ1 and AZ2. The application servers are working. The DynamoDB is a global service, so everything are working. Now, on the other hand, this is no, I've moved to active. Oh my god. Oh, it's not meant to be. Sorry. So we're talking about what are they calling it now? Warm standby. So you see, everything that is working here is not everything that's working here. You see, the EC2 instances are working on this AZ alone. You see, the Aurora cluster snapshot are still going on. The replica is still going on. But you can see this other AZ is not functioning. You see, the EC2 instances, nothing is going on here. So in the case of a disaster, it will take for these ones to scale up. We get it. To take for these ones now to scale up, these two instances to scale up. Did we get it? So now if we now look at the active, everything is working. Look at it now. Everything that's working here is working here. Hmm? We see the dynamo. So the DynamoDB, which is a global, which has a global feature, everything that's working in this is continuous backup and everything, continuous replication, everything is happening fast. So we understand now. I believe this term is already this that we've already explained it very well now. So like half capacity of the build of the main building. Yes, like half capacity of the main building. That's for warm standby. That's for warm standby. So let's move now. So key things to take away. Backup and restore cheap but takes the longest to recover. Pilot light keeps essential components running for faster recovery. For warm standby, partially active backup environment for quicker scaling, then fully redundant across multiple locations for immediate failover with no downtime. Yes, exactly. You've answered yourself. That's good for warm standby. So now let's move. So now let's talk about AWS Backup. So I kind of pulled up some things. I did my research on as a cloud practitioner level to know how much of information we need about AWS Backup. So I've given us just as much that we need for the cloud practitioner level. So let's go. Like when we're talking about backup and restore. So it's literally how you can actually save some of your backup your workload and everything. So AWS Backup is a fully managed service now. This is a service that makes it easy to centralize and automate data protection across AWS services in the cloud and on premises. So key things to note here, that is a fully managed service. When you want to back up your data, you understand, or anything, you understand, either from on premise or from a region to another region or anyone. So you understand. So centrally manage and automate backup across AWS services. So most AWS services are supported here, but not all AWS services. So you don't need to create custom script and manual processes. All happens automatically. So you just have to create a plan, set up a plan, and that's it. And you're good to go. So supported AWS services are EC2 instances, UBS, Amazon S3, all these. I just quickly pulled up some. So now support cross-region backups, support cross-account backups too. So now let's quickly look at it. So how it works. So we can see AWS Backup is centralized and automated data protection across AWS services and on premises by using the AWS Backup console and APIs or CLI. Quickly, who can tell me what what's the full meaning of API? The first person to type the full meaning of API and CLI. The first person to type API, the full meaning of API and CLI. Maybe I'm going to API CLI. No, both together. I've not seen that immediate before. I'm just seeing this name. Oh. Some people can type fast. Okay. Okay, application programming interface. I know somebody will make this. Application line interface and command line interface. Okay. Okay. I said it. I know. I media and I know only one. They always. Well, I guess I'm just seeing I media. So let's go on. Let's go on. Like when Prof. Mifeoluwa was explaining to us, she explained to us how we can have access to AWS services that we can have access to through the console, through APIs, that's SDKs and CLI. So how do backups? How do you do backups? How AWS backup works? So you create a backup plan, you configure settings such as backup frequency or retention policy. So all you have to do is just create a backup plan. So you choose from which you want to back up your maybe data to, maybe you want the database, just back it up to a database or a storage in S3 or anyone or an EC2 instances. So assign application and service resources. So your everything is protected, resources are protected automatically. So there's monitoring, can configure, restore, audit, and report. So just have that back of your mind that you don't have to do anything with AWS backup. All you need to do is for you to just create up a backup plan. So let's proceed. So now I pull this up. I was checking the what are they calling that exam so let's say brochure for the cloud practitioner level, and I saw this AWS Elastic Disaster Recovery. I know we've been talking about disaster recovery, so we have to know that this is different from disaster recovery. Disaster recovery is, think of it like it's a term, it's a general term. But elastic disaster recovery is a service. Now, if you've gotten to the point whereby I've just spoken now, can you tell me to fly? Can you tell me to fly? I didn't say I was going to give anybody anything. No. I just said maybe, maybe. So can you tell me to fly? I guess we have some couple of slides to. Okay. Can I get a fly? Okay. So I believe we are understanding it. Okay. Okay. So now, elastic disaster recovery. AWS Elastic Disaster Recovery. Now, Elastic Disaster Recovery, DRS, I don't know why they abbreviated to DRS, but that's what it is. It's a fully managed service that helps organizations quickly recover their applications and data in case of a disaster, like system failures or outages. It simplifies the disaster recovery process by continuously replicating your on-premise or cloud-based applications to AWS. So now it works with other cloud services too. So take notes, and on-premise. Mm? So now let's see. Let's take an analogy, for example. So imagine you have a copy of your store physical on, always ready in another city. If something bad happens to your main store, like a flood, you understand, or a fire, the backup store is ready to open its doors and serve customers almost immediately. So the same thing with DRS ensures that your digital business operates similarly by having a ready to activate version of your system in the cloud in case of a failure. So with AWS Elastic Disaster Recovery, it helps you to prepare for recovery, not just prepare for recovery, it also helps you to recover um, your applications or this is from on-premise to the AWS cloud. So now let's look at this diagram, for example, now. So as you can see, there's an agent on the on-premise. As you can see, there's an agent here which carries out the process of moving whatsoever is here to the AWS cloud. Yeah, disaster recovery, but it's elastic. There's no E there. So, how many of us can see this architectural diagram? And let's zoom it. Let's zoom it, and let's try and understand. Let's zoom it and let's try and understand it. So I'd like all hands to be on deck now. So I'd like us to do this together. Let's zoom it and let's see what I believe we can see it now. Is there anybody that cannot see it? If you cannot see it, let me know. You Yes, what? So let's all zoom it. Let's zoom it. Let's zoom it. If you are zooming it right now, can you say zoom? Can I get a zoom? Can I get a zoom? If you're actually zooming it and you actually figured out the architectural diagram, can I get a zoom? What gadget are you using to have access to this zoom? That's good. Oh yeah, I like that. So if you're using your phone, you can slide it like this. See, you can slide it like this. You can slide it, you understand, and zoom it. Olusola, you're not saying application is clear. Yes, zoom. So I like every one of us to took our hands into this now. We'll be seeing architectural diagrams. My colleague has brought up different type of architectural diagrams. So can we by ourselves just look at this architectural diagram and try to understand what's going on? Hmm? So let's zoom it. Let's look at it. Let's study. Let me give us like 2 minutes. Sorry. Sorry. That's the slip of cursor. The slip of cursor. So if you understand the architectural diagram that is here, can I get a O clear? Can I get a O clear? Can I get a O clear if you understand the architectural diagram that you can see in front of you? Can I get a O clear? Co clear. For you, so that what happened? O blur. Okay, O blur. I've told us Zoom it now. Is your go to your co-clear. So okay, co-clear. What's going on? Eau clair blur. Okay, eau clair. Okay. So what for our own level, eau blur. If it's blurry, all you need to do is to use your YouTube. Go to that setting icon, click on it, adjust your quality settings and the rest. What's it clear? Okay. So now let me just take you. So now remember we said it. So at your left hand side, if you're facing your screen, I can see it well, sir, but not clear in understanding. No, no problem. So that's what I want to explain now. So now let me explain. Let me explain. So we don't need to really, really understand it. But the key things that I want us to understand is this. Huh? There's an agent that does this work. Hmm? No, my screen is not blur now. You have to, Abby, let me find out. So I've just confirmed now. It's not. Okay, so those of us that are saying is blur, you have to go to your settings and you understand, do some. So, sir, is this, let me quickly explain this architectural diagram so we can take questions. I don't want us to uh, finish this class by now. I want us to, because if I want to eat eba, and if you eat eba at night, so if you won't be able to fight in the gym because your stomach will be heavy. So I want to quickly hurry up and hit my eba before it's cold. So now if you can see on the left hand side, you have a data center or the cloud. I think difference is the agent that runs. Who is this Oluwakemi? Ah, I officially announce you as a professor, Professor Oluwakemi. So now let me quickly move on. So now you see you have a data center, like we said, or cloud, definitely not AWS cloud. You understand? Maybe like GCP or thereabout. And on the right hand side, we have AWS cloud. So how do we now make this movement from this on-premise or cloud to AWS cloud? Now there have to be a guide, and this guide there is called a replication agent. So a replication agent. So it does the work. So you understand? It does the work to move it from on-premise to the AWS cloud. So you understand. So if you look at this arrow, so the agent control protocols, so you can see from here the continuous backup happens to this EC2 instances, then to the EBS volumes. So what you need to understand here is the agent that does the work. It does not just happen like Holy Spirit doing something. No, there's actually an agent that does the work in moving it from here as a replication agent to here to the AWS cloud. So an agent is going to be on the on-premise on the AWS cloud, you understand, which automatically helps direct everything to the AWS cloud. So with this few point of mine, hope I'm able to convince you, and not to convince you that what God can I use now? That we've all understood. So if there's any question, hit me with your questions now. Hit me with your questions. Hit me with your questions. If it's clear, say what is clear. Or just say oh clear. So we can call it a day. I wanted to do, maybe I'm going to, should I do an hands-on? Convince and not to confuse. Yes, what God cannot do does not exist. So do you want me to do an hands-on? How many of us were able to see that hands-on that I did? That creating a bucket policy video. How many of us can see it? Clear. What's going on? What's not clear there? Oh, clear, code deep. You want me to do an hands-on? Okay, what's not clear? Olushola, what's not clear? So now, some people are saying, some people want to go, some people want to go. Nobody should go yet, though. We'll send that. I will send my own attendance, so nobody should go yet. Let's finalize it. So if you can't see it, I've already confirmed. No, I mean I'll do a video and send across to us like I did. But I am trying to see maybe I should not do, because for the cloud practitioner level, there's the all you need to do is to know is just the what it can do. Finish. You don't need to know any other thing. So Olusola, you said it's not clear. Can you tell me what is not clear? It means the LMS adds another. Yes. The diagram explanation. So now I said zoom it very well. Now you're talking about elastic disaster recovery, how it happens, the workflow. So we are seeing how we can perform a recovery from somewhere to another place. So in this case, from a data center or another class service provider, maybe GCP, maybe Azure, maybe Oracle. It's not 3 minutes to go. Let's wait. Let's wait. Miracle. Miracle. Let's wait. Let's wait. Just some few minutes. Let me explain. So what happens is this. There's the AWS cloud here. At your right hand side, you can see it. And there's the data center on the left hand side. So how does this data move from here? How do you recover from here, the data center, to AWS? So there's an agent. So this agent is called a replication agent that does the work. You understand? So this agent has to be on the on-premise in order to perform these tasks. So move it from here to here. So it can either be in an EBS domain, in an EC2 instances, in an S3 bucket. It depends. So I believe that I'm able to explain. So let's call this a day. Thank you so much, every one of you. Can you give yourself a round of applause? Can you give yourself a round of applause? I've not closed yet. There's something I still want to. Can you give yourself a round of applause? Can you give yourself a round of applause? We are now. Clap now. Okay. Okay. So you guys are, you ladies are truly, truly great. For a lady to be able to, most people think cloud computing is very simple. Trust me, it takes the strong ones, the ones that are determined to be able to do cloud computing. So thank you so much. Myself and my colleague and the whole staff, we truly appreciate your time spent here and being consistent at all time. So have a wonderful night's rest. Bye. So we are going to see you. I didn't say I was going to send card. Oh. Did I say I was going to send card? So bye, everybody. We are going to see you when again is that next week, Monday. So thank you so much.